Hello students, in this session we will try to learn the components of Bitcoin. In previous session we have studied how the transactions are processed in Bitcoin. We have studied this from users perspective, how the transactions are processed in the Bitcoin network. So in this session we will try to go into the details of Bitcoin components. It is difficult to complete these components in one session. So we will try to start studying these components in this session, and we will continue in the next session also. So dear students, I could not upload the session yesterday because I was busy in completing the work assigned by the university. That work was urgent. So don't worry, we will complete all these sessions of this week before the Saturday. So we know that syllabus of second unit is related to the Bitcoin, in which we have to study the creation of coins, payments, uh, double spending, Bitcoin scripts, Bitcoin peer-to-peer network, transaction in Bitcoin network, block mining, block propagation, and block relay. And second part of the unit is related to the consensus mechanism in the Bitcoin. So in previous session we have studied how the payments are processed, and we also studied the double spending problem. Now we will focus on the components of Bitcoin. So as we know that blockchain was introduced with the invention of Bitcoin in 2008. Its practical implementation of Bitcoin occurred in 2009. In 2008, a groundbreaking paper entitled Bitcoin, a peer-to-peer electronic cash system, was written on the topic of peer-to-peer electronic cash system under the pseudonym Satoshi Nakamoto. Satoshi Nakamoto has introduced the Bitcoin, and its practical implementation appeared in 2009, and no one knows the actual identity of the Satoshi Nakamoto. Then in previous session we have studied the definition of Bitcoin. Bitcoin is a combination of peer-to-peer network protocols, software that facilitate the creation and uses of digital currency named Bitcoin. So decentralization of currency was made possible for the first time with the invention of Bitcoin. And major advantage of Bitcoin is that there is no need of any central authority like banks or any government or federal system. This is completely decentralized system based on peer-to-peer and network. And the double spending problem is resolved in the Bitcoin. So we know that how the double spending problem is resolved. In previous session we have studied. For avoiding the double spending problem, there are different mechanisms in the Bitcoin. It uses the nonce. What is the use of nonce? How the nonce is used to prevent the double spending? We have studied in the previous session. Then we know the main components of the Bitcoin. Uh, the first component of the Bitcoin is digital keys. Digital keys are used to digitally sign the transactions, proving the ownership of the Bitcoins, and public keys are used by the nodes to verify the transaction. So in coming slides, I will see the details of this all components one by one. Then next component of the Bitcoin is addresses. sender and receiver addresses. Then transaction is the core component of the Bitcoin. There are different types of transactions. Coins may be created, coins may be sent from one user to another user, and transactions are not encrypted. Everyone in the Bitcoin network can view the transactions, and these transactions are publicly visible to all the nodes in the Bitcoin network. Then blockchain miners. Blockchain miners are nothing but the nodes in the Bitcoin network, Bitcoin or blockchain. Miners, what is the function of miners? We know that in previous sessions also we have studied what is the function of miners. Miners are responsible for validating the transactions. Miners verify the transactions, and when certain number of miners verify the transaction, that transaction is get finalized. Block is created and block is inserted in the blockchains, and for validating, for verifying the transaction, miners get the reward. So in terms of Bitcoin network, the miners may get additional Bitcoins for verification of the transaction. Bitcoin network is a blockchain network, because blockchain network provides a infrastructure for Bitcoin. Miners, wallets is a client software. The client software available on the end user's machine or mobile. The wallet software is used to store the private and public keys and Bitcoin addresses. It performs various functions such as receiving and sending the Bitcoins. So in next slides, we have to study these components one by one. It is not possible to complete all these components in one session. In this session we will take the introduction of components one by one, and gradually we will explore these components in the coming sessions. So first component of the Bitcoin is digital keys. So on the Bitcoin network, possession of Bitcoins and transfer of value via transactions is reliant upon private keys, public keys and addresses. The transfer of Bitcoins depends on the relies on the private keys, public keys and addresses. And for generating the public key and private key in the Bitcoin network, Bitcoin network uses elliptic curve cryptography, ECC. There are different types of public key cryptography, RSA and other types also, but this Bitcoin network uses the ECC, elliptic curve cryptography, to generate the public keys and private key pairs in the Bitcoin network. Private keys are required to be kept safe and normally resides only on the owner side. The node who will create the private keys on that machine, these private keys will reside. These private keys are saved, and these private keys are kept securely on the owner's machine. The machine, the node who will create the transaction. So private keys are used to digitally sign the transactions, proving the ownership of the Bitcoins. So public keys exist on the blockchain, and all network participants can see the public key. Public keys are derived from the private keys due to their special mathematical relationship with the private keys. Public keys and private keys have special mathematical relation, and they are determined by using the mathematical functions. So cryptography is nothing but a branch of mathematics. So if I will try to explain this cryptography in detail with all the mathematical formulas, then students you may get overloaded. So I am trying to avoid the mathematics. So if students want to go into the details of this mathematical background of cryptography, then you can go through the different books like Network Security by William Stallings. Every computer engineer must read this book. network security by William Stallings. So once a transaction signed with the private key, that transaction is broadcasted on the Bitcoin network, and public keys are used by the nodes to verify the transaction. Then addresses. Bitcoin uses a special mechanism to generate the addresses. A Bitcoin address is created by taking corresponding public key of the private key. Public key and private key are determined by using the same mathematical function, and they have special relation. So a Bitcoin address is created by taking the corresponding public key of a private key and hashing it twice. Hash function is applied twice, first with the SHA-256 algorithm and then with the RIP-MD160 algorithm. Two hash functions are used. First SHA-256 and then second RIP-MD166, and resultant 160-bit hash is then prefixed with the version number and finally encoded with the base 58 check encoding scheme. So you will try to understand. We will not go into the details of this mathematics, but you can remember the steps. Address is created by public key of a private key, and then hash function is applied twice. First hash function which is applied is SHA-256 algorithm. Second hash function which is applied that is RIP-MD160, and then it will generate a 160-bit hash value, and this value is then prefixed with the version number, and again after applying the hash function twice and it is prefixed by the version number, then it is finally encoded with a base 58 check encoding scheme. The Bitcoin addresses are 26 to 35 characters long and begin with digit 1 or 3. Depending on the type of address, we will see what is this number 1, 2, 3 in coming sessions. So a typical Bitcoin address looks like a string shown. You can see how the Bitcoin address looks. It is prefixed by the digital numeric number 1. Then base 58 check encoding. Bitcoin addresses are encoded using the base 58 check encoding. This encoding is used to limit the confusion between the various characters such as 0022 as 0011, as they can look the same in different fonts. So some numbers may look similar like O and 0, then Roman 1 and number 1 in different fonts. So to avoid this confusion, this base 58 check encoding scheme is used in the Bitcoin addresses. As we know that Bitcoin address is generated from public key, then two hash functions are used, base 58 SHA-256 and RIP-MD, and then it is prefixed by the version number, and then after that it is encoded by using the base 58 check encoding. So this scheme is used to avoid the confusion between the various characters. Characters sometimes look same in different fonts. So encoding basically takes the binary byte arrays and converts them into the human readable strings. Then multi-signature addresses. Sometimes it is necessary to sign the Bitcoin with multiple private keys. So as this multi-signature name implies, these addresses require multiple private keys. In practical terms, it means that in order to release the coins, a certain set of signatures are required. This is known as M of n multi-signature. So how many number of signatures are required? That is M of n. That means we require M signatures out of n. This M is the threshold. Minimum M signatures are required to sign the Bitcoin transaction. So this is M of n multi-signature. Here M represents threshold or minimum number of signatures required from n number of keys to release the Bitcoin. Transactions, as we know that transactions are at the core of the Bitcoin ecosystem. Transaction can be simple as just sending some Bitcoins to a Bitcoin address, or it can be complex transactions depending on the requirements, and each transaction is composed of at least one input and output. Input can be thought of as coins being spent that have been created in a previous transaction, and outputs as coins being created. If transaction is mining new coins, mining means verification. If transaction is for verification, then there is no need of input, and there is no need of digital signature also. Yeah, we will study about this transaction in detail in coming sessions. We have to study the transaction life cycle. So it is difficult to study. You may get overloaded if we try to understand, explain this transaction life cycle and all the concepts in the same session. So we will keep it for next session. We will study the transaction life cycle in the next session. So transactions are the core of the Bitcoins. Transactions can be as simple for sending some Bitcoins to some Bitcoin address, or it can be complex transaction, and each transaction is composed of at least one input and output. This is the basic concept of transactions. Some transactions are required for verification, and if we do the transaction for verification of coins, then there is no need of input and there is no need of digital signature also. Transaction fees. We know that for verification, miners get the transaction fee. Why the transaction fee is required? Because if you want to verify the transaction on priority, then you can increase the owner who will create the transaction. That may increase the fee to get the more reward, so that the miners can pick up the transaction early, and the transaction may be completed before time. So to complete the transaction as early as possible, the owner may increase the fee, and because of more fee, miners may pick up the transaction early. So transaction fees are charged by the miners. Why the transaction fee is required? To complete the transaction in time, the miners require the fee for verification. Transaction fee are charged by the miners, and the fee charge is dependent upon the size and weight of the transaction. So size in the bytes and weight of the transaction. So what is this weight and size? We will see in coming sessions. So transaction fees are calculated by subtracting the sum of inputs and sum of outputs. A simple formula can be used: fee equal to sum of inputs and minus sum of outputs. So we will discuss more about this transaction fee in the next session. So in Bitcoin network, transactions fees are increasing day by day because Bitcoins are limited. They have intentionally kept Bitcoin limited, and if we want to complete the transaction on time, then the owner increases the fee so that the miners can pick up the transactions early. So because of that, transaction fees are very variable. That depends how many time you want to expect to complete the transaction. If you are willing to complete the transaction as early as possible, then you have to give more incentive to the miners, so that miners can pick up your transaction early. Then transaction pools. So we know that transaction needs verification, and after verification of transaction, the block is created and block is inserted in the blockchain. But before creating the block, where your transaction will reside, there must be some temporary storage, because block is not created until the transaction is verified, until the transaction is finalized. And before finalizing the transaction, the transactions are stored in transaction pools. This is the temporary memory where your transactions will be stored for temporary purpose before creating the block, before finalizing the transactions. So these transaction pools are also known as memory pools, and these pools are basically created in local computer memory, that is RAM, by nodes in order to maintain a temporary list of transactions that are not yet confirmed in a block. Until the block is created, we need to keep the transaction somewhere for temporary purpose, because if the transaction is not verified, then that transaction may be discarded. We have to keep it somewhere, so that transactions are kept in RAM by the nodes, and when the transaction is finalized, then block is created and transactions are added in the block, and then that block is added in the blockchain. So transactions are included in a block after passing the verification and based on their priority. So transaction at high level contains information. Transaction contains information like metadata, inputs, outputs. Transactions are combined to create a block. So we have to, there are data structures. These are the data structures: transaction life, transaction data structure, then metadata, inputs and outputs. It is not possible to study all these data structures in this session. So we will keep it for next session. So in next session we will study transaction data structure, inputs, outputs, metadata. That we postponed it for the next session. Then metadata. This part of the transaction contains some values such as the size of the transaction, number of inputs and outputs, hash of the transaction, and log time field. In DBMS also we have seen this term, what is data. Metadata is data about the data, and this metadata gives the information about the data. So in blockchain, in Bitcoin also, this metadata is same meaning. This metadata gives the information about the transaction. What is the size of the transaction, what is the weight of the transaction, how many number of inputs are there, how many number of outputs, list of transactions, hash of the transaction, and then timing information. So all this information is nothing but the metadata, and every transaction has a prefix specifying the version number. These fields are shown in the preceding example: log time, size, and version. So we will study about this metadata in the next session. We will keep it for next session. We will have more discussion on this metadata in the next session. Then verification. Verification is performed by using the Bitcoin's scripting language. So we will see in detail what is the scripting language. We have to go into the details of the scripting language. So scripting language, Bitcoin uses a simple stack-based language called script to describe how the transactions can be spent and transferred. So on user's wallet, we need some language, and by using that scripting language, transactions can be created and different operations on the Bitcoin network can be performed. So from computer engineer's point of view, this scripting language is more important. Students, I want to say, as a computer engineer, we should learn less and we should spend more time on coding. As an engineer, we have to focus more on programming aspect of any subject. Whatever subject you will study, you learn less, but you spend more time on coding. If you spend more time on coding, then that will be more helpful to the helpful to us. So this scripting language is important. If you it is those are interested in programming, I want to say to that students, you go into the details of scripting language on internet. You find the information which kind of scripting language is used for Bitcoin network. What are the different methods, what are the different functions available in the scripting language, how we can write the programs for Bitcoin network creation using the scripting language. Try to learn more about this scripting language. So Bitcoin uses a simple stack based language called script to describe how Bitcoins can be spent and transferred. And this scripting language is not Turing complete. That means there are no loops to avoid any desirable effects of long running or hung scripts on the Bitcoin network. So this scripting language is a very simple language. There are no loops. So these loops may have undesired effects. Some programs, some transactions may go in loop. So to avoid such kind of things, the scripting language don't use loops. They have a simple uh, opcodes, and opcodes are followed by the operands. So this scripting language is based on a fourth programming language like syntax, and uses a reverse Polish notation in which every operand is followed by its operators. So it has operands and it has operands, and it is evaluated. The scripts are evaluated from left to right using the last in and first out stack. So scripts are various opcodes or instructions to define their operations. Opcodes are also known as words, commands, or functions. So it is not possible to study the scripting language in detail, but in coming session we will try to learn some opcodes and some examples of scripting language, because as an engineer we have to focus on this scripting language. uh, Studying theoretically any subject is not important for us. How we can practically design the Bitcoin network, at least how we can design the wallet software, and how transactions are done using the scripting language, that is more important to study. So students, thanks for watching session. So in this session we have studied components of Bitcoin. We have taken the introduction. We are not gone into the details of these components. We will go gradually, slowly into details of components one by one. Uh, I request to the students, keep studying and use the internet. Various sources are available. Also use some videos on YouTube to go into the details of this subject. So thank you for watching the session.